Hi everyone. This is going to be a tutorial explaining to you the Cisco Packet Tracer, the network simulator that you will be using for your assignment. I will be showing you how to download the network simulator based on your operating system. I will also be explaining to you the interface of the software, and in the end I will be demonstrating to you three simple scenarios in Packet Tracer to help get you acquainted with the interface and to help prepare you for your assignment. Now, to download the Packet Tracer, you can download it from the official website using this link. So if you go to skillsforall.com/resources/lab downloads and click enter, if it's your first time, it would ask you to sign in. So you will find the sign in button right here. Click sign in and then create an account and enter the Cisco Networking Academy website. If you have already downloaded it before, or if you have an account on Cisco, then probably you would be signed in and you would be redirected to this page. Now, we have three versions for three different operating systems. If you have the Mac OS, download the first one, Ubuntu the second one, and Windows the third one. I will be downloading the Windows version right here. Now I already have the software. I will just cancel the download right here. So if I fast forward and show you, it's downloaded for me here. You can go in and install the software. For me, I installed it on my C drive. You can just install everything based on the default installation choices that you find, and then once it's installed, you can just type Packet Tracer or Cisco Packet Tracer, and you would find it right here. So I will enter. So, like I said in the beginning, it's a network simulator. So in this Packet Tracer program, you can simulate the networks that you logically design on paper for whatever purpose that you want. You will see that in the assignment, you will probably be given a simple scenario and you have to implement it. You have also seen such examples in your lectures as well. It can be a network for your home, it can be for an apartment, for a company, and so on. So once you open the Cisco Packet Tracer right here, you find the some options down. Let's talk about these. So if you hover on the first one, you would see network devices, and on the last row right here, you see the options that you have. So in the network devices, you can add routers, you can add switches, hubs, wireless devices, and so on. You can extend your program as you like, adding as much or as many network devices as you want. For this tutorial and for your assignment, you will see that you will be just using the basic networking devices that you have learned: switches, and devices or hosts, routers, and the links between them, Ethernet cables, wires, or copper wires, and so on. So when you, for example, check routers, you would find different types of routers. You see here 2901, 2911, 829, and so on. Many different routers. The differences between these routers is basically the difference between any network device from the other. So if I just, for example, click on the first one right here, so I will just drag it. If I just click on my mouse and drag it to the schema right here and click on it, you will see that, for example, so I'll just wait for it to boot. you will see that, for example, this type of router by default has two Ethernet interfaces, gigabit interfaces. So this is one type. For other types, for example, if I just drag this one to 811, which is different, you will see that it has two fast Ethernet interfaces. So different interfaces, different functionalities, options. What to choose, that depends on your design and also depends on the requirements. So if you have a specific requirement given to you in the assignment, follow it. If you don't, then you are free to use whatever router that fits your schema. So that is regarding the types of routers, and this also applies to switches and devices and so on. You would see that right now. So if you want to delete something from the schema right here, just click the delete button on your keyboard and then go to the device that you want to delete. So you would see that it changed to this sort of X shape. Hover over the device that you want, left click on your mouse, and then it will give you this confirmation message that you want to delete the router. Just click yes. Same thing here. So now we are in delete mode. If I want to go back to insert mode or just freelance mode, I will click the escape button on my keyboard. So these are the options for routers. Same goes on for switches. You have different types of switches. I will show you what I will choose. What are the basic ones? Basically, hubs, wireless devices, and so on. You can find many. This is regarding network devices and devices which or hosts in this case. So also many to choose. So if I check the basic end devices here, I have some PCs, laptops, servers. So I can have a PC, or I can have a laptop, or I can have a printer, or I can have a TV, and so on. In this scenario, or in these scenarios that I will be implementing, I will be using a normal PC. You can also use PCs in your assignment, that would be fine. So I'll click delete and go back here, and so on. So components and so on, many different options. So regarding the connections, these will be the wires or the cables that you will be using to connect between different devices. So as you know, switches require if you want to connect PCs to switches, we basically connect Ethernet cables, right? So you will choose the connections from here. Now this sign right here automatically chooses the connection for you. So for example, if you're trying to connect a switch to a router, and you click this connection link right here, so let me show it to you. So let's say I have a switch right here, and then I have a router right here. Let's also add an end device, a PC. Now this automatic chooser, once clicked, it basically automatically identifies for you that, or it understands that this is a PC and this is a switch, so it chooses the convenient type of cable for you. So if I click here again, I go from PC and then I connect it to switch, it automatically connects it. Also again from switch to router, it automatically understands. I will be showing you what I will be choosing from here and why it's useful in my opinion not to choose the automatic chooser. You can do that, it's totally fine. Now once again I click delete, and then I clicked on the cables and they're deleted. Escape, back again. So let me delete all of these. Right, so we talked about the three most important things that I will be demonstrating here, and basically the three things that you will be needing for your assignment: network devices, end devices, and connections. Okay, so let's start implementing the first scenario. So with the first scenario, I say that I will be designing a network for a home that has two PCs, which are hosts or end devices, and a switch. So let's start by doing that. So I will go to end devices right here. I will choose two PCs, and I will go to network devices and I will choose a switch. I will use this switch right here, 2960. Now, between PCs and switches, you can use the copper straight through cable right here. And it's useful to use the cables manually, not through the automatic, not the automatic way, because using this you can specify the which port that you want to use. So for example, a PC has one Ethernet port, as you know, so it only gives me one option, right? Fast Ethernet 0, so I will choose it. But when I connect it to the switch, I will see that this switch right here has 24 Ethernet ports, means that I can connect 24 PCs to this switch right here. I will choose the first one for simplicity, and I will do the same thing. I'll use the copper straight through wire from this PC using the default or the only Ethernet cable for this PC, and I will connect it to the switch, and I will choose the second one. Notice that the first one has disappeared, right? 01, fast Ethernet 01, because it has been chosen for PC1. So I'll choose it right here. Now after choosing, now the most important part is configuring the IP addresses. So for the switch, the switch is a layer 2 device. It recognizes the MAC addresses, so I don't need to do anything regarding configuring the switch. All good for the switch for now. Regarding the PCs, since they are connected to a switch, then it means that they are on the same network, right? So let me explain again from the beginning. So when I click on PC, I left click PC, then I have this menu, so physical config, desktop programming, and so on. And there are two ways for me to enter the IP address that I want to assign to the PC. I can enter through the terminal right here, or actually through the command prompt. I can enter through the command prompt. I can say ipconfig, IP address, this. But I will choose to enter it through the interface, which is the easier way. Now, I will go to config. I will choose the fast Ethernet 0 interface right here because it's the one that's connected to the switch. And I will go right here to IPv4 address, and I will write the address that I want. So I will just choose the address arbitrarily here. In your assignment, if you're given a specific address, you need to comply to that address. So for me, I'll choose a class C address, so 192.1.0.1, for example. Okay, and I will not choose .0.0 because the first address is the network address. Always in the in any subnet, it's the network address. So we always start from address 1. And if I just click on the subnet mask right here, it automatically generates the subnet mask for me. It understands that it's a class C address. So the last 8 bits are only reserved for host, and these are, as you know, the network addresses right here. So now I configured the IP address for the first PC. Now let's go to the second PC. Go to config, fast Ethernet, and they will be on the same network. So .0.1.2, or I think that was .1. I'll check it now. So it automatically generates it. So let's check just here. So let me choose it to be 192.1.1.1, and this is 192.1.1.2. So in the same subnet right here. And now, how to check if if the configuration is correct, if the messages are received. If you go up right here, you can send some data packets. So you use this simple PDU right here, click on it, and then you will see this white envelope right here. Click on the source and then the destination. So I want to send a message from PC1 or PC2. In this case, it's named PC2. and I want to send it to PC3 right here. So if I click here, if you check down here, it says successful, and it shows the source and shows the destination. Bottom right here you can find it. So this is in real time. So also the packet tracer allows you to check the how the packet is actually routed, or it allows you to check at what time the packet reaches the certain network device, at what time it leaves from. If there's a problem, it shows you where did the message got stuck and so on. You will see this with routing in a bit. So if I send a message, so if I want to check it in simulation mode right here, we checked it in real time. If I want to check it in simulation mode, I can just click the play button right here. It shows you that it went from PC2, went to the switch, and then the switch redirected it to PC3, and the simulation went again. Now it's like it said, it's in progress. It's a bit slow. If you want to fast forward through the simulation, you can click this fast forward button right here, and it will fast forward for you with time. Okay, so this is the first scenario, a simple scenario right here. If you want to delete these data packet results that you have sent, you can just click the delete button right here. So now everything's deleted. Let's check the second scenario. So the second scenario says that we have an apartment with 2 homes, each with 2 PCs and a switch. So let's check this right here, and let's add the condition that they are connected to a router. Okay, so let's say that they are all that this apartment with the 2 homes are connected to one router. So let me add some extra end devices. So I will add one here, I will add one here, and like the specification, we also, each of them has 1 switch and 2 PCs, and we have 1 router. So it doesn't matter, like I said, which router you choose. I will choose 2811 right here. Okay, so let me add the connections again. So like I said, I will choose the copper straight through. So fast Ethernet 0 to 01. Go again. PC5 fast Ethernet 0 to 02. And then also I will use the straight through copper wire right here between the switch and the router. So from switch, I will use the 03 port. This goes to the router at the 00 port right here, and from the switch, this goes to the 01 connection right here. All right. Now, in this simple scenario right here, you can see that, so if I click on the router right here, it shows me that by default the router has 2 Ethernet interfaces right here. So it has 0001, okay, which is very convenient because I have 2 switches and they both fit. So 00 was connected to switch 1, 01 was connected to switch 2. Now, if I had a third switch, for example, let me bring a third switch, and if I try to connect this wire, so the third switch, I have a lot of options, to this router right here, you will see that I don't have an extra port that I can connect the third switch to this router. So what I can do, these routers are configurable, so I can add some components too. If I go to physical, and I first of all, you need to turn off the router, so you will see here the turn off button. Turn it off, and you can see these modules right here, what you can add, what you can't add. So let's read some of them. So for example, this says this module right here provides 2 Ethernet ports. This one here provides 2 fast Ethernet interfaces. This one here provides a WAN interface card and so on. This one right here, you will see it later, provides some serial ports which will be used to connect routers to routers. So let me choose this one, for example. Let's choose the two fast Ethernet interfaces. And if I just, so once you click, you see that it changes right here, right? So this is the device itself. I can just drag it and put it in the place on the router right here. Now, once I put it, I need to turn on the, so now it's added. So you will see now that I had two extra interfaces for the router. I can turn on the router again. So if once I turn it on, I go to config, you will see that I have two new Ethernet interfaces or fast Ethernet interfaces that I can use to connect different switches to, and so on. I can add as much as the router can handle. If this router type, for example, can't handle the amount of switches that you want to connect to, then you can choose different routers and so on. So now it's configured. Let's check. So if I have a switch right now, and if I want to connect it, then look, I have two new options that I can connect to, and it can be connected. Now I won't be using this, but I just wanted to show you this will be helpful in your assignment, and it will be helpful actually, I think, in the next scenario that we will be implementing. So again, I click delete the switch, the connection gets deleted immediately. So now that we have, so we already have the IP addresses for these devices, right? I chose 1.1.1, and for here I chose, as you know, 1.1.2, and here I chose, so I didn't choose actually, this is a new network. So since they have a router between them, it only makes sense that I put them on different networks, but I can also put them on the same network, it doesn't matter, on the same subnet. But to show you that the routing here is actually working, I will be putting them on different networks. So here I chose again 1.1.1. Here I will be choosing 192.1.2.1. Okay, so I will be moving on to the next address, and here I will be choosing, so if I go to fast Ethernet right here, 192.1.2.2. okay, so this is on 192.1.1.0 network, and this is on the 192.1.2.0 network right here. So now if I try and send some data packets, so this is working, this is let me do it in real time, so I'll switch to real time. This is successful. If I send from PC4 to PC5, also successful. No problems with the switches, everything is okay. But if I try and send between PC2 to PC4 on different networks, you will see that the simulation here will fail. I'll send again, I'll show you. It will fail. Why is that? Because I can show you that through the simulation right here actually, which will make more sense. So let me try send a message again from this PC2 to PC4. So I'll delete this. I'll send from PC2 to PC4, and then I'll go. Now the message goes from the switch. What happens later is that, okay, maybe this wasn't the best example. Let me show you in a different way. Or actually, let me explain it, because it won't be visible to you what's going on right here. So I will just say it. The reason is the reason the simulation right here failed is because I don't configure some IP addresses for the gateway router. So I said, okay, I said this is a router right here, and I added the components for it and I did everything, but I didn't configure any addresses for it, which is expected not to work. It's just a device that's connected to the switches, but nothing is configured. So I need to configure the IP addresses of the gateway, so that when the message reaches the router, it knows where it came from, and it knows where the message should go to. Because this is a very simple scenario, like two switches are only connected to the router, but in practical scenarios, you will see that you can have many switches connected to a router. So you need to define the gateway addresses. And how you can do that? So remember, gateway addresses are addresses that should be within the same subnet with your the network address that you're using. So here I'm using the 192.1.1.0. So here, and remember that this switch is connected to the fast Ethernet 00. So here I can just go to the fast Ethernet 00, and I will connect to 1.1.3. Okay, so this was 1, this was 2, this will be 3. This can be 1, this can be 2, this can be 3. It doesn't matter. It's just important that it's in the same subnet that you're using for the hosts that are connected to the switch, basically. So once I configured, or once I mentioned that, okay, this is connected to the IP, so this is the gateway address of this router from this connection right here. I need to add this gateway address to the PCs also, so that the message can be conveyed correctly to the router. So it's 192.1.1.3. I need to go to the PCs individually one by one. I will go to the first one, and the first option that you will see right here, config, it shows here to you the default gateway. So if I go ahead and write it, it will be configured correctly. So let me write it here again. Not the fast Ethernet. Let's go back to settings right here, and it's the same. .1.1.3. Let's check. Yes, it is. And for this network, you know that here I have a different network, which is 192.1.2. Okay, so here I can, and remember that it's connected to the 0.1 interface, so I can say 192.1.2.3, right? Because this is 192.1.2.1, and the other PC is 192.1.2.2, so this is 192.1.2.3. So here I choose 192.1.2.3, and here I choose 192.1.2.3, and now I can say that the routers are correctly configured. Now remember also, so to check that the connections are correctly working, or in more true terms, that they are working or on, these triangles right here should be in the color green. So as you can see here, they're green, but here they're red. Why is that? Because simply by default the interface Ethernet cable is turned off. So you see port status right here, just click it on, you will see that it turned green, so now it's on. And for the second one, turn it on, and now you will see that it turned green. So let's try again sending the message. So from this, in the same switch, so I'll choose real time to make it faster. If I send to a different PC, the first one normally fails. So if I send again, and we check the simulation right here. So let me send from PC2 to PC4, and I will begin. We can check it through the simulation. So message goes from PC2, goes to the switch. then goes to the router, and we have a problem. So, or we don't. Let's see if the message will be correctly received. So if I fast forward through the simulation, now the acknowledgement is sent back. So let's see why it failed. Probably we missed something, so I'll delete this. So this is turned on, and we have configured the IP addresses, and we have configured the gateway right here. Same gateway. Okay, everything is good. So I'll just try to fast forward the time right here. So let me go to real time. I will fast forward here using this button. Probably it takes time to configure. So I would send from this PC to this PC. Yes. So the problem was that you might face this also because you will be having a more complex scenario that you have to implement. If you see that, if you're 100% sure that all your IP addresses, all your configuration is correct, you can just fast forward the time here. Sometimes it takes time to boot, or for the algorithm to once you also apply some booting algorithms, it will take time to converge, I would say. So just fast forward the time here a bit so that it you make sure that everything takes its time to configure. So if I send a message here again from PC3 to PC5, it's normal that it fails the first time, but I go back, I send again, you see a success. So let's try it. Success, and so on. So yeah, this is for the second example. Now let's look at the third scenario. And I say in the third scenario, we have the apartment in the second scenario, so this apartment right here stays the same. And let's just imagine that it's connected to a faraway home. So this is a imaginary scenario, but let's just, for the sake of argument, implement this so that I will show you one last important functionality that you will be adding to your schema in your assignments also, which is the routing between the routers themselves. So let's say I will go to network devices. Let me choose the same router again. So 2811 right here. And I will also choose a switch, the same one right here. I go to end devices, and let me just choose one PC for simplicity. Now again, I will choose a copper straight through cable from the switch, or from the PC to the switch, and the same from the switch to the router here, and I will choose the 00 port. Now, as you know, between routers themselves, we use serial interfaces. We don't use this Ethernet interfaces. So I will be using the serial DTE wire right here. But if I check my routers, if I check the configuration right here, I don't see a serial interface. So with the method that we learned just before, we need to add some serial interfaces right here. So I can just choose this WIC2T. As you can see here, it says this is a high density smart serial connector. So if I choose it, and before that I need to turn off my router. If I choose it, it will be right here, and then I add it. I'll turn my router back on. And if I go to configuration, I will see that I have two new serial interfaces added to me right here. So in this way I can connect two routers to each other. So I think it's booted, yeah. So all good. Let me turn it on from now. And so I did it for router 3 right here. Let me do the same thing for the second router. So I turn off my router and then I go to this module right here. I drag it and I drop it. Turn the router again and then go back to config. Okay, so it finished booting, and now as you can see I have two serial interfaces. I'll turn it on from now. Now I can use this serial connector right here, the serial DTE, and I will go from router 3 here. I will choose the serial connection and I will connect it to router 4, and I will choose this serial connection right here. And green arrows means I turned them on, so everything's good. Now, what's there to add? So first of all, let me configure the IP addresses for the host. So let's go on the same pattern. I chose 192.1.1 and .2, so this time I'll choose .3 and I'll choose 1 right here. And let me choose the gateway IP address right here. So if I go to the settings, to the fast Ethernet 00 right here. Let me choose 192.1.3.2. Subnet is here, and let me add this to the PC right here. So 192.1.3.2. So now everything is good in this connection right here. So, and let me turn this on. So now it's turned on. What's left for me now is to configure the serial connections right here between these two routers so that the messages can be correctly conveyed into the desired destination. So I will configure the serial addresses right here. I will just choose different, say, addresses. It doesn't matter in this scenario. I just choose something different to show you that it can be different. It's not like the gateway address. With the gateway address, I chose something that needs to be on the same network, but here I can choose, also I can choose class A, class B addresses. It doesn't matter for the serial interfaces. But we choose if you're given specific guidelines or specific range of addresses or addresses in your assignment, then you must follow it. But here I'm just showing you what you can do. So let me choose 193, I don't know, .1.1.1, for example. And now I have the subnet mask right here. Now I said that they can be different, but so as you know, the serial connection is two-ended, right? So I have a connection here to router 3, and I have a connection here to router 4. So I have a pair of addresses always for the serial connections. One to this end, one to this end. Now, the IP address for the serial connection itself can be different from the network address for the switches that it is connected to, but it needs to be on the same network regarding the pair of addresses right here. So for example, I chose here 193.1.1.1, then this part of the connection right here also should be on the same network. So I will choose, for example, .1.1.2. Okay, let me check. Okay, we're all good. Now this is not enough. So if I try here and send the message, for example, from PC2 to PC6, and I start the simulation. I go through the switch, then you see that so this was turned off red. Let's check why. Okay, this has been deleted. I'll check why. Okay, so let's configure the IP addresses again. So this was 192.1.1.3, so I will choose that here. Okay, now it's good. And this was 191.1.2.3, so this would also go to the 01. For some reason it was deleted, so now it's configured again, all good. I will delete, but still this won't make the message reach the, so if I check the simulation, let me check the simulation right here. So it goes to switch, goes to the router, you can see here, but then it doesn't recognize the other router because it doesn't have a routing algorithm applied to it. So it goes back to the switch and we have a failed message right here. So I'll delete, and we have to configure the routing algorithm that we will be using. Now, by default here, Packet Tracer provides for you two routing algorithms. So you have static routing algorithms, which includes specifying the hop count and so on. But we will be using the routing information protocol algorithm, which is based on distance vector routing algorithm. You can check it from your lecture notes to remember what does it do, but it's a dynamic routing algorithm. And what to do here, so once you click here, the routing or Packet Tracer just requests from you the IP addresses that you are including in your schema. It doesn't it dynamically specifies the hops and so on. So you need to add, in our case right here, you need to add 4 things. So the first thing that you need to add is the network address that you are coming from. So for example, in route 3, I have 2 network addresses, right? I have .1.1.0 and I have 192.1.2.0, and I also have the IP address of the network that's connected to the other router. I need to specify it also here. So 192.1.3.0. Now I also need to specify the network address for the serial connection that I have right here. So if I remember, it was 193.1.1.0. So I will add it and then we can check it. So if I check the serial, yes, 193.1.1.2 is the host and 0 is the network address. And I will do the same thing right here for this router right here. So let me add 192.1.1.0, 192.1.1. And yeah, like I said, you don't add every host, you add the network address, and it automatically identifies the hosts in that subnet. So 192.1.1 or .3.0. I should have chosen more clear IP addresses. And now I choose 193.1.1.0. Okay, so I'll check. Yes, .1.1.0, and I have the 3.0 and so on. Yes, so now they're added. Everything's good. So let me delete these. And now everything is configured. Let me fast forward the time right here so that everything is just configured and good. So if I try and send a message right now, let me use the simulation environment right here. Let's go from PC2 to PC6, for example. Let's check. So message goes from the switch. Let me fast forward, goes to the router. From the router, it goes to the router 4. Now it goes to switch 5. And in the end, if I fast forward, yes, goes to PC6, gets the acknowledgement back, and it failed in the beginning. So this is for the first time. Now let me go to real time again, go from PC2, go to PC6, and now I see that it's successful. Like I said again, it's normal for it to fail in the first time. Later, everything gets configured, and all the routers recognize the hosts in the network. So this was it for this tutorial. In your implementation, you will see that in your assignment, you will have much more hosts than this. So in this simple example, I have 2 hosts in every switch and so on. You might have 20, 30, 40 hosts or more or less. You will see that. It's enough to represent every work group or every group that you will be representing with 2 or 3 PCs. You don't need to put all the hosts. That is all from me for this tutorial. I hope it was beneficial, and I hope you do well in your assignment.